So for part 7, a container holds 1,000 pens, half of which are red. Select a simple random sample of 50 pens, and S is going to count the number of pens that are red. Now, S can be modeled by a binomial distribution even though the sample was selected without replacement. This without replacement implies that we don't have the independence portion that we need. Our way to get around that is looking for our 10% condition. If our sample size, which simple random sample of 50 pens, is less than 10% your population size, it was pulled from a population of 1,000, then you can treat it as approximately independent. So 50 is less than 100. There we go. So the trials can be treated as independent. So now that I know I can use the binomial distribution to approximate this answer, we're going to find the probability that I get exactly 40 pens, and it does say the probability formula. Technically, I could check my work here with Binom PDF, but I am asking you to use the formula. So the formula uses our combination notation. Remember, this is not a fraction. This is 50 things. We are choosing 40 to be successful. So this is that exponential definition, but there's also just the NCR feature in your calculator. Excuse me. We will multiply by the probability of success. Half of the pens are red. Raised to the power of x, we want 40 successes. So then I need 1 minus p, so 1/2, to the n minus x power, meaning I want to be successful 40 times, but I need to then mean that I fail 10 times. So when you put that in your calculator, it's going to give you a very weird answer. It's going to look like 9.12. It's going to look like an answer that's not possible for probabilities, but at the end of your calculator, it'll say E -6. Remember, that's your calculator saying scientific notation. It's trying to say use the 912, but move your decimal point 6 places to the left, which means it's real unlikely that you're going to get exactly 40. For part C, you're supposed to find the probability that more than 30 pens are red. So more than 30. What I want to point out about more than 30 is it's the same thing like if you think of all the things X can be. Remember, when you have binomial, you can have no successes. You can have 1 success. We're interested in more than 30, and it stops at n successes. So the numbers that are more than 30 are 31 through 50. So this is the same thing as the probability that my random variable is greater than or equal to 31. Our calculators don't work with that. It works on the cumulative side of things. So I basically need to do the complement. I need to get rid of all this stuff I don't want. So I don't want 30 and below. So I'm going to do the complement of my binom CDF. And I'm going to tell it that we have 50 trials for my number of pens in my sample. The probability of success on each trial is 1/2. And that the X value I would like it to include is 30 so that I could take those away and be left with 31 and above. So when I do that, I get, my answer key's wrong. I actually have to do this one. So 50 trials, 0.5, 30 success. So I'm getting about 0.0595.